here's the process. U prime V minus U V prime over V squared. Now some of you have learned the low D high minus high D low thing. Yeah, forget that, because, well, if that makes you happy, then go with it. But I don't go that way, because I can never forget I can never remember which part is the D high and the D low, and forget it.
No, it's low and derivative of high, times derivative of low.
Low D high minus high D low. Yeah, over low squared. Yeah. Yeah, I can never remember that. I can never remember where the D goes. So I just go with this. Okay. So now let's work it. Let's name our parts. Is this a product or a quotient, first of all, up here?
Quotient.
It's a quotient, right? How many of you are going to have trouble remembering what product and what quotient mean? Okay, you are a product of your parents' multiplication. You'll never forget it now.
Multiplication.
Yeah. Right?
Yeah.
Why?
Well, now you'll never forget it. So product is multiplication. Okay? I know, right? My U is defined as the, well, you'll never forget it. Mnemonics are supposed to be unforgettable, that's why. My U is my top function. My V is my bottom function. So far, so good? So then what's U prime? U prime equals? Find x squared minus 20x. What's V prime? Now we have all the pieces. Plug and chug, y'all. Don't overthink it. Here we go. The derivative is, find all your parts and just plug them in. U prime, 9x squared minus 20x. It honestly takes longer to write it than it does to find the derivative. Times V, 11x minus 4x to the fourth, minus U, which is 3x cubed minus 10x plus 15, times V prime, which is 11 minus 16x cubed,
So it's like
over
okay.
V squared.
So U prime
11x
is the first station,
minus
and then there's
4x
regular
to the fourth.
V, and then you have to do
Oh, that's
regular
messy.
the U minus the prime of V. Yeah, just make it confusing. Okay.
So let me label the parts.
You don't know what happened? No.
Here's U
Uh-huh.
prime, here's V minus U, V prime.
You have to keep
V
looking
squared.
back at the normal one. So
It took longer to write it out than it did to perform the actual derivative parts, didn't it?
Is this the answer?
This is the answer.
You don't have to solve it, you just write it
You
out.
solved it.
Okay.
You're asking, do I have to simplify it?
Like,
God, no.
get the X, we don't have to get the X.
Please, for the love of Mike, don't try to simplify this unless you're expressly told to simplify this answer. Then you must FOIL out and blah, 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 blah. Why? Because if you get this right, but you get your FOILing wrong, I gotta dock ya. You did bad math. Don't do that. Stop while you're ahead. Okay? But here's the downside to stopping while you're ahead. The back of the book has the simplified answer.
Oh, it's not.
So what do you do?
You ignore that.
You go to your office.
Correct.
Yeah.
Right, you
That's one way. Another way is plug a number into your answer and plug the same number into their answer. And if you get out the same slope, chances are pretty damn good you got the right answer, just in a different form. I cannot say this enough times because you guys are going to come to me throughout the semester. It always happens. Why does my answer look different from the back of the book? Because I didn't ask you to simplify. So you're going to have to do some work on this one way or another. You either simplify it and really, really improve those algebra skills because you're doing it all the time, and hating life. Or you plug a number in and see what you get out. Plug a number into theirs and see what you get out. Same number, same answer, you're good. Groovy? Okay. So you either do the work on the front end or the back end. But I think the back end is less work. Questions? How do you feel? Is it bad? No, it's not, is it? Again, you guys are doing calculus in your heads. You know more than you think you know. Give yourself some credit. Anybody want to take photos? I'm going to erase soon. Okay. Don't do it. Stuff isn't bad. The hardest part is just maintaining composure while you look at the mess in front of you and say, okay, well, this is something I can use this technique to solve it. That's the hardest part. It's not ideal. Okay. You want me to move?
No, just because I can't do that.
Okay. Yeah. Let's do some more.
Invested in a tripod and set up my going back around.
Yeah,
Stop
right.
messing
Right.
around. Just start working.
Might as well. Yeah, how many times do I have to rewatch this? Maybe 5.
Damn it! It's back in my brain. Is it tight?
Bless you.
Health? German?
So you're just like, help! You sneeze. Help!
Help!
Okay, so we're gonna do this.
Okay.
So,
Product or question? Quotient.
Quotient. Because there's a divide and not a multiply.
Because there's a divide and not a multiply. So identify your parts, guys. This is the hardest part. You're just going to want to jump into the derivative. Do yourself a favor and label your parts. It's going to make your life a lot easier. Here's my top, U. Here's my bottom, me. What's U prime?
9x powered by 2.
I hear a lot of people sort of quietly whispering it. Good. What's the denominator?
7 minus 50 x 4.
Awesome. Plug and chug. The derivative is U prime times V minus U times V prime over V squared. I like. Makes my life so much easier. On exams, this is what I want. Don't take it any further. Again, if you make a mistake in foiling it out, first of all, I have to follow you, which ticks me off, because then I'm like, I didn't foil this, now I have to foil it. And then if you get the answer wrong, I have to dock you. Don't do it. Don't do it. Any questions? You guys are like, damn, this is easy, right? No, it's not bad. I wouldn't say E for easy, but
E for efficiency.
E for efficient? It's much more efficient than, say, trying to do limit as h goes to 0 of f of x plus h minus f of x all over h, right? On this.
H, yeah.
Yeah, you can be like, no! Not okay. Let's do another. How about this one? F of x equals 3 plus x cubed times 14x minus the square root of x. Product or quotient? So, what do we do? First of all, is it all pretty? No. Can we make it pretty? Which term do we need to change?
So where did that?
Should we write it, right?
Yeah, it's on B, so minus x to the 1/2. We're just gonna convert this to that. That's really hard to see. Minus x to the 1/2. Okay.
So it's you.
All right, you guys ready? Label your bits. No, this is not my red pen. Here's my U. Here's my V. What's U prime?
3x power of 2.
Yeah, 3x squared. And what's V prime?
Why do these have to be letters that are similar to each other?
Do we have all the parts we need to take the derivative here?
Similar letters, like U and a V. They're gonna be E, J.
What's the derivative, guys? Friggin' song. Insane.
Now you have to put it
Do we
in
just,
What's the
we just
derivative?
write
this.
negative 3?
Yeah. So it would be this 3x squared plus.
Do I care what form you leave that first x in? No.
This one first.
The thing about calculus is you have to be able to see the forest and the trees. In the first step, for any of these problems, you have to look at the forest and say, is this forest a product or a quotient, right? And then we break it down once we've decided if the forest is named product or quotient. Then we have to look at the trees and say, okay, we look at the details. This is my top function, so that's my U. This is my bottom function, that's my V. And then we go in and look at the leaves. When we take derivatives, we go term by term, okay? So we're like zooming in on this forest or this tree or these leaves eventually. But you have to start with the forest. Don't try to dive in and do the leaves immediately, because you'll be sad. Okay? So far, so good? You guys worried when the other shoe was gonna drop? You're like, yeah, this is not so bad.
It's too quiet.
It's too easy. Yeah.
Too quiet, yeah.
Things are gonna happen. This is a problem.
Too long. That's easy.
I've had like all of 15 minutes up here, and I'm like, I don't know what else to tell you guys. It's really that simple. So now let's throw you a loop.
Can never be easy for longer than
How about
20 minutes?
let's do this? Are we all okay? Okay. All right. Sorry. What is interesting? All right. Y equals 200x minus 100x over 3x plus 1. Yeah, that's too easy. These were much harder looking, weren't they? Yeah. Forest. What do we have here? Are we sure?
200x
Where's the product? Gesundheit.
200x.
What's this?
It's a minus.
Is that a product?
that's
No. So this is a straight derivative. That's what I like to call the ones that just go straight to this here. This is straight derivative here, as far as I'm concerned. This is a straight derivative. We just go right to the good stuff. This one is a quotient, and it involves a little extra work. So how many of you wanted to just slash and burn and go right through and say that's 200 on the derivative? I'm betting a lot of you. Resist the temptation until all of your parts are set up. Then do that. So let's figure out our parts of our quotient and the derivative parts, and then we can put the whole derivative together. So what's my u on this quotient? 100x. What's my v? Yeah, 3x plus 1. So what's u prime? 100. What's v prime?
3.
3. How many of you are like, wait a minute, where'd that 1 go again?
Cancels out.
Yes, you killed it, killer. There's killers out there. Great, so now,
We leave off the negative, we don't make that 100 negative 100.
no, so, yes. This is tricky, because that negative is just like saying plus a minus 100x. So you can include it in here, or you can leave it out here. But be careful, because if this contains several terms, you would have to distribute that negative. So I'm a fan of leaving it out front. Does that make sense?
Yeah.
Okay. There's where, that's a negative, Jess. So this is where the math gets a little tricky. Okay. So now we can go through and take the derivative, guys. Which is what? Now we can go term by term. What's the derivative of this term? 200. What's the derivative of this term? U prime times v minus u times v prime divided by v squared. And that's why that negative out front becomes important, because if we were to FOIL all of this stuff out, then we could distribute that negative sign. So I just like to leave it out front. Questions? This one would be fairly easy to simplify, right? We're distributing 100 into this, 3 to 100x, and then we FOIL that sucker out. But is it gonna get us anywhere? Is there anything we can cancel?
3x plus 1.
Really?
X.
Really? Let me ask you guys a question. So let me address some of your funky canceling concerns. How many of you are like, maybe I can cancel that? I just don't know. How many are like, absolutely I can cancel that? How many of you are like, I absolutely cannot cancel that? Let's do an experiment. Do the math in your head. What's 2 times 3? 2 times 7. What's 6 plus 14? 20. Divide that by 2, that equals?
10.
Okay, so we're good with that. Now do this. 2 times 3 plus 7 divided by 2. What's 2 times 3?
6.
Plus 7 divided by 2. 6 and a half. Okay. If I pull a 2 out of every term and cancel here, will I still get 10?
Yes.
Wait a second. 14 divided by 2 is 10. Yeah, if I pull 2 out of everything, I'll get 3 plus 7 divided by 1, right? What's 3 plus 7? 10. Okay, so now let's just cancel those 2's and see if this still works out. What's 3 plus 7? Is that 6 and a half? No? So can we cancel something that doesn't have it in every single term? No. Is there a 3x plus 1 in all of these sets of terms? No. So can we cancel it?
Okay.
No.
Cutting into
by,
Like the first parentheses over the bottom minus the second over the bottom, just like move the
Mhm.
bottom so it's on both sides.
sure, and then you can cancel it on the first set of terms. But
That's it.
do you wanna do that? That's a lot of work. For very little reward, I would say no. Don't bother. Just leave it like this. This is good enough for government work. Because in the end, you guys, at the end of the day, he's laughing, but at the end of the day, it's true. We don't end with this, we end up plugging numbers in. So why spend your time simplifying something that you're just gonna plug a number into and get a number out? Don't waste your time on the simplification, because in the real world, we don't stop with this. We use it as a tool to get numbers out of it, okay?
If you had to simplify 3x plus 1, it would be 3x plus 1 because there'd be another difference, right? 3x plus 1.
Are you saying that I can still cancel that?
No, I was just talking about the denominator.
You're talking about, yeah, we'll have 3x plus 1 times 3x plus 1.
Yeah,
But I can't, look at the pattern.
yeah.
I can't cancel something out of the numerator and the denominator unless every set of terms contains that thing.
Oh, that is the
So
logic.
this does not have 3x plus 1 in it. I
Yeah.
cannot cancel it. There's no point in moving it around.
That's your logic, yeah.
Yeah. Okay.
Thank you.
All right. How do you guys feel about this? The hardest part is looking at the forest first, right? And resisting the temptation to just go through slashing and burning. At least initially. Here's your handout. Frickin' song. Ah, yes, you're welcome. 3, 8. So there's some practice. Yeah, you're welcome. There's some practice problems in here. I want you guys to stick it out for me for a few minutes. I'll walk around and help you. What's that? Light. So careful. What would be prime become? Yeah. So what you can do is split that 4 up. I'll show you what I'm worried about. What page am I on? Last one. 2. So I would split that up like this. 7x cubed over 4 plus 10x over 4. So this is when it's beneficial to do, who said, can we just split them up? Yeah, this is when it's beneficial to do that. When you have a denominator that's not a function, you can pull it apart and then take derivatives term by term by term.
With it.
Does that help? So it's really a judgment call, and experience is all that you need to see it. But for now, it can be really frustrating. You're like, why did I not do it here, but I did it
It's just
here?
how it is. That's just
Yeah.
how
That was.
it's how it is.
Don't take
Oh,
it
okay,
hard,
it's
dude.
okay.
It's right.
Just accept it.
You just walk through the process. So A in that first term is gonna be 7 over 4.
So this is 6x plus 10. 10x cubed.
Sometimes I forget what I've written on these handouts. I should probably take a look at it, huh? Yes.
So this would be.
What's up, Brenda?
Hi.
Hi. Hi. It's hack. Okay. So this is something that you want to be on your cheat sheet immediately. So your check is this formula right here. I'll put it up here. Square root of x becomes x to the 1/2. And the pattern is because a 1 and this is a 2. So it doesn't matter what kind of root you get and what kind of power you have. So for example, we have a 4th root of x to the 5th. What's that going to become? Use the pattern. Good. So if you have this, you can do any of them.
So I guess like what I'm confused is like we go from the top to the bottom.
If this were on a denominator, like so.
Oh yeah.
Let's just say we have 4/3 x to the, or 4 over 3x to the 4/3. If I pull this up top, imagine grabbing this by its hair and yanking it uptown. It's really violent. Imagine grabbing it by its hand and leading it uptown. What comes with it? What's tied to that exponent? Just the x. So then,
And why does it become negative? It's just really
because of the nature of algebra. So if you were to test, this, you would get 1 out because that's like saying 2 over 2. Okay, so if you were to practice with real numbers in your calculator, you'd see the pattern real quick. That bringing this uptown is the same as just having it downtown with a positive sign. So this would be like that. Does that make sense?
Yeah.
It's just the nature of math.
Okay. Thank you.
Yeah, you're welcome.
Jeez. Just quit it.
All right.
Just multiply it in
Who
there.
else? East.
60, right? It'll be 60. 6 times 10. 60x
Cubed, yeah.
and then what's 6 times 5? And then multiply it again.
6 times 30.
120.
Okay.
And what's x?
You do 10 times 30.
Is it
30 times 10, yeah. 300.
yeah, but wait, what happens to the x's?
They stay there, yeah.
So it's 120x? Is it 120x?
Yeah, 120x plus 30x.
It might help Maria to pull. Maria, it might help to pull that 4 out in front so you can see clearly that this is your constant coefficient. Does that make sense? And then put the x next to it. Yeah.
Oh, and then combine like terms? Oh, okay. So, from biggest to smallest?
None of these are, this is x cubed, this is x squared, this is x. Oh wow.
What? I don't think we did this one right.
She's on the back page.
I don't think we did this one.